Hello students. Hello and welcome to this video. We have 24 more problems on determinants, so we will solve 12 in this video and 12 more in the video tomorrow. So the link to download the PDFs will be in description, as well as at the end I will show you how you can download and maintain an updated copy from the website. I will also show you my question answer website from where you can ask and answer questions. So if you have any questions related to math, you can ask me there. So without further ado, let's get started. Question 161 says that show without expanding that 2, the determinant 2, 1 plus I, 3, 1 minus I, 0, 2 plus I, 3, 2 minus I, 1 is purely real. So what we do here is we take complex conjugate and exchange rows into corresponding columns. So our delta bar, that is the conjugate of the determinant delta, is same as delta. And since delta is equal to delta bar, that is the determinant and its complex conjugate are equal, the determinant is purely real. We know that if there is a complex number z and its complex conjugate z bar are same, then it's a purely real quantity. So very easy question. Question 162 says that show without expanding that the determinant x minus 3, 2x plus 1, 2, 3x plus 2, x plus 2, 1, 5x plus 1, 5x plus 4, 5 is independent of x. So what we do here is we split on the basis of second column. So our determinant becomes x minus 3, or rather the second column is important. The second column becomes here 2x, x and 5x. And here it becomes 1 to 4. Now if we take x common from here, this second column and third column will be equal. So the two columns being equal, it will become 0. Now we have the second determinant, okay? So we split it. So you see, one side will become x, 3x, 5x, and the other will contain minus 3, 2, 1 and all the constants. So those will be constants, right? So we take x common from here, we have 1, 3, 5. Now what we do is C1 is equal to C1 minus C2. And this determinant we say k. So we have 0, 1, 2, 1, 2, 1, 1, 4, 5. Once we have that, we do R3 is equal to R3 minus R2. We have got 0, 2, 4 and 0, 1, 2. Now you see, this row is exactly double of that. So we can take 2 common from here. And once we do that, and we subtract, or rather we subtract C3 is equal to C3 minus 2C1. C3 column 3 is equal to, no. There is something wrong here. This should be row. Row 3 is equal to row 3 minus 2 row 1. Okay. Once you do that, this last row will become 0. And therefore this determinant is 0. And your k remains constant. So it is independent of x. Question 163 says that if a and x are real numbers and n is a positive integer, then show without expanding that a raised to the power n minus x, a raised to the power n plus 1x minus x, a raised to the power n plus 2 minus x, and so on. We go on increasing the powers of x, and minus x is there in all that will be equal to 0. So we have this. So what we do is we do R2 is equal to R2 minus R1 and R3 is equal to R3 minus R2. So our row 2 becomes a n plus 3 minus a raised to the power n, a to the power n plus 4 minus a to the power n plus 1, a raised to the power n plus 5 minus a raised to the power n plus 2. And similarly, row 3 becomes a raised to the power n plus 6 minus a raised to the power n plus 3, a raised to the power n plus 1 minus a raised to the power n plus 4, a raised to the power n plus 8 minus a raised to the power n plus 5. So now what we can do is we can take a to the power n common from the second row and a raised to the power n plus 3 common from this third row. So outside we will have a raised to the power n times n plus 3, and the second row and the third row will become identical, and therefore the determinant will be equal to 0. Question 164 says that find sigma r is equal to 2 to the power n minus 2 to the power r, n minus 2 cr minus 2, n minus 2 cr minus 1, n minus 2 cr minus 3, 1, 1, 2, 1, 0, where n is greater than 2. So what we do here is we do column 1 is equal to column 1 plus 2 column 2 plus column 3. Okay. So when we do that, our column 1 becomes, so let me see once. Okay. Alright, column 1 plus 2 column 2. Okay, there is something wrong here. Okay. This should be 0. Okay. And this over here is minus 1. Okay, there are two mistakes here. One typing mistake is here. Instead of 0, I have typed 9. And over here it should be minus 1. Otherwise, this won't be 0. So once we do that, the first column becomes n minus 2 cr, and these two become 0. And then we expand. So minus 2 to the power r, there should be a bracket here, a bigger bracket. And cr minus nc0 minus 2 times nc1, and which is essentially 2n minus 1 plus minus 1 to the power n. Question 165 says that if ABC are, I'm not sure this might be correct, there may not be need of bracket. Let me verify this once, okay? So this is sigma that, and we evaluate against this, okay, and this is 0. No, this is all right, this is fine, we don't need this, we don't need bracket, this is fine. This will be 0, right? So if this is 0, then it is all right. Let me think once more. So this is n minus 2 cr. So we do column 1 is equal to 2, column 2 plus column 3. So if we add these two, this becomes n minus 1. Okay, there is a mistake here. This should be NCR. Okay, this should be NCR. And once you do that, it should be equal to NC0 minus NC0. And okay, there seems to be calculation mistake here. Take care of this. Okay, I need pen and paper to do this. So the basic idea is we solving the determinant, and then you can solve this. Question 165 says that if ABC are non-zero real numbers, show without expanding that b square c square bc b plus c square a square ca c plus a square b square ab a plus b is equal to 0. So what we do here is we do r1 is equal to a r1, r2 is equal to b r2, and r3 is equal to c r3. And then we take ABC out from the first two columns. So once we do that, we will have ABC outside and BC, CA, AB, 1, 1, 1, A times B plus C, B times C plus A, and C times A plus B. Then we perform column 3 is equal to column 3 plus column 1 and take AB plus BC plus CA out. And that will make column 2 and column 3 same, and the determinant will become 0. Question 166 says that prove that the determinant B plus C minus A minus D, BC minus AD, BC times A plus D minus AD times B plus D, C plus A minus B minus D, CA minus BD, CA times B plus D minus BD times C plus A plus B minus C minus D, AB minus CD, AB times C plus D minus CD times A plus B is equal to minus 2 times B minus C times C minus A times A minus B times A minus B times B minus D times C minus D. So we see that if you put D is equal to C, the determinant reduces to 0. Similarly, C is equal to A, or A is equal to B, or A is equal to D, or B is equal to D, or C is equal to D also reduces the determinant to 0. We also see that the degree of polynomial of the determinant is 6, and thus determinant is equal to k times b minus c, c minus a minus b, a minus b, b minus d, c minus d. Now we put a is equal to 0, b is equal to 1, c is equal to 2, d is equal to 3, we evaluate k is equal to minus 2, and thus the desired equality is proven. Question 167 says that prove that bc minus a square, ca minus b square, ab minus c square, ca plus ab minus bc, bc plus ab minus ca, bc plus ca minus ab, a plus b times a plus c, b plus c times b plus a, c plus a times c plus b is equal to 3 times b minus c times c minus a times a minus b times a plus b plus c times ab plus bc plus ca. This x is extra addition to the, okay. So by putting b is equal to c, we see that the determinant reduces to 0. Similarly, c is equal to a or a is equal to b also reduces the determinant to 0. Also putting a is equal to minus b minus c or ab is equal to minus bc minus ca makes the determinant 0. We see that the degree of polynomial of the determinant is 6, and thus the determinant is equal to k times b minus c times c minus a times a minus b times a plus b plus c times ab plus bc plus ca. Now we put a is equal to 0, b is equal to 1, c is equal to 2, we evaluate k is equal to 3, and thus we have the equality. Question 168 says, prove that 1 m plus n minus l minus p whole square, m plus n minus l minus p to the power 4, 1 n plus l minus m minus p whole square, n plus l minus m minus p whole to the power 4, 1 l plus m minus p whole square, l plus m minus n minus p whole to the power 4 is equal to 64 times L minus m times L minus n times L minus p times m minus n times m minus p times n minus p. So we see that here again L is equal to m makes the determinant 0. Similarly, L is equal to n is equal to p, m is equal to n, m is equal to p, n is equal to p also reduces the determinant to 0. We also see that the degree of the polynomial of the determinant is 6, and thus the determinant is equal to k times L minus m times L minus n times L minus p times n minus n times m minus p times n minus p. Now we substitute L is equal to 0, m is equal to 1, n is equal to 2, p is equal to 3, and we find that k is equal to 64. And hence we have proven the required equality. Question 169 says that if u, v, w are differential functions of x and suffixes denote the derivatives with respect to t, prove that d upon dt of u1, v1, w1, u2, v2, w2, u3, v3, w3 is equal to u1, v1, w1, u2, v2, w2, u4, v4, w4. So we differentiate the determinant and we get u2, v2, w2, u2, v2, w2, v3, v3, w3 plus. We differentiate the second row now. Here first row was differentiated. We get v1, v1, w1, u3, v3, w3, u3, v3, w3, and now we differentiate the third row. So first row is u1, v1, w1, u2, v2, w2, and u4, v4, w4. Now if you look at the first two determinants, in the first determinant, first two rows are identical. And the second determinant, last two rows are identical, so they are 0. And therefore, this is the only value. Question 170 says that if capital Y is equal to Sx, capital X, Z is equal to Tx, all the variable being differential functions of X, prove that capital X, Y, capital Z, X1, Y1, Z1, X2, Y2, Z2 is equal to capital X cube, S1, T1, S2, T2, where suffixes denote the derivatives with respect to X. So we have capital Y is equal to Sx. So Y1 is equal to S1x plus Sx1. Y2 is equal to S2x plus S1x plus S1x1 plus Sx2. That is Sx2 plus 2 S1x1 plus S2x. And similarly, Z will be Tx2 plus, Z1 will be T1x plus Tx1 and Z2 will be Tx2 plus 2 T1x1 plus T2x. So our determinants on the left hand side will be this. Okay. We substitute for y1, y2 and z1, z2. Once we do that, we take out x common from the first row. It becomes 1ht, and the second and third rows remain same. Now what we do is, we do r2 is equal to r2 minus r1 x1, and r3 is equal to r3 minus r1 x2. Once we do that, we have two zeros here, okay, and this one will become, the second row, second column will become s1x, because sx1 will be cancelled, and this will become t1x, and this will become s2x plus 2 s1x1, t2x plus 2 t1x1. So once we have that, we expand along 1, okay. So this x we can take out common, so it becomes x squared. And then you see that what we have is, we can split along this 2s1 x1 and 2t1 x1, and we take out x common from here. And when you split, you will see that the second order determinant, the rows will become identical here. This will be multiple of 2 and that will be 0, and that's how we get this result. Question 171 says that if f of x, g of x, h of x are polynomials in x, find the condition that f of x, g of x, h of x, f of alpha, g of alpha, h of alpha, f of beta, g of beta, h of beta, which is a polynomial of degree 3, is expressible as a times x minus alpha whole square x minus beta. So this a may not be there. Okay, we'll see. So this is our capital F of x. So f of alpha is equal to 0. Okay, because first two rows become equal if you substitute x equal to alpha. Now f dash x will be f dash x, g dash x, h dash x. Now f dash x is equal to 0. Okay. All right. So if f dash x is equal to 0, then f dash alpha will be 0, because alpha will become a repeated root there. All right. Now f of beta is equal to 0, because first and last rows are identical here. If you put x equal to beta, thus x minus alpha whole square, x minus beta is a factor of f of x. So the required condition is f dash x, g dash x, f of h dash x, f of alpha, g of alpha, h of alpha, f of beta, g of beta, h of beta is equal to 0. Now we move on to question 172. This a is not there. This a can be a constant. Okay? So that the determinant sin x plus alpha, cos x plus alpha, a plus x sin alpha, sin x plus beta, cos x plus beta, b plus x sin beta, sin x plus gamma, cos x plus gamma, c plus x sin gamma is independent of x. So we differentiate this with respect to x, right? So if you differentiate it with respect to x, it will become 0. So how do you differentiate this with respect to x? So if you differentiate this with respect to x, let me think, d delta upon dx is equal to 0, hence it's a constant. So I think I need to elaborate more on this, okay? Saying only this is equal to 0, it will be 0, of course, okay? So I will expand this solution in the next video, right? And we will see that d of delta upon dx is equal to 0, and therefore it's a constant and independent of x. Okay, so let me see if we differentiate with respect to x. So this column becomes sin alpha, sin beta, sin gamma. Okay, sin alpha, sin beta, and sin gamma. No. Columns won't be differentiated. First we differentiate the row. Yeah, column will, first we differentiate the row. This becomes cos x plus alpha. This becomes minus sin x plus alpha. And this becomes sin alpha. Okay. It will be somewhat involved. Okay. I can't do just verbally here. Okay. Let me see more. We can split this. We have to do some splitting. I will have to evaluate it 172. Anyway, so we come to the end of this video, and let me show you the website from where you can download the book. You come to gustavok.org and you can download the PDF from the second, third, and fourth link of Algebra, Trigonometry, and Trigonometry. And when you download, it won't have the date, so you take this date and add it to the PDF. I cannot add the date to the PDF because that will make the existing link invalid, and after 15 or 30 days, you should come again and download the PDF and add that new date to the PDF. Also note that there will be a lot of typing mistakes, so be very careful while editing this. I see that there are lots of typing mistakes, so for the question answer website, you can come and ask the questions here. And if you look at the tags, you have algebra, calculus, ordinate geometry, geometry, probability, trigonometry, and if these tags don't satisfy your question, then you can use simply mathematics. So you can come and ask questions here or give answers. So with this, I will end this video here, and I hope that you enjoyed the video and got something to learn. So we will finish the determinants chapter in the next video, and I'll see that I expand more on 172. Okay, so with this, I will end this video here, and we will meet again tomorrow. Thanks a lot for watching the video. Stay curious, keep learning, and most importantly, enjoy.